also known as ensemble technique in some cases. Okay, so what is basically ensemble learning? So in simple terms, you can define it as, so for example, you have certain models and you want to use and combine these models into one single model for better performance. So this is what ensemble learning is. Okay, so what are the key points of ensemble learning? If you say there are high performance, the second thing is combines multiple models. Next, we can see is what are the key aspects of this ensemble learning. Key aspects. So first of all, uh, consider this is our data. Consider this as our data. There are multiple rows. These are, let's say, feature 1, feature 2, feature 3 and so on, and this is our output feature. Right, and there are multiple rows and columns. What will happen? This data might be evenly distributed. Okay, it might be evenly distributed or not. Same as in the case of uh, data qualities and features. Okay, so what will generally happen is that, for example, you have a model M1 and here you have a model M2, and you pass the same data, this data also and this data are equal to this model. They may give different accuracy A1 and A2, and the performance will vary based on the data you give. So the case is that model performance varies with data. Okay, so the thing is, it is not possible for a single model to learn all the features and perform well, right? It is not possible that you have F1, F2, F3 and so on Fn, and a single model will able to perform well on these all features. It is not possible. So what in practice we do, we take certain models, let's say M1, M2, M3 and so on, and we'll try to give different features, let's say F1, F2 and so on, F3, even some combination of features, and whichever model learns which features well, we'll use them for the better performance, right? So I think this might think you might have understand. Okay. And the key feature regarding that, let's say you have different models. One model gives the feature accuracy A1, second model gives you A2, A3. Okay, but when you combine this, you get accuracy A. You maybe get by averaging A1 plus A2 and so on divided by n, and this will be obviously better. So try to understand the intuition. Let's say there is a quiz. Okay, and you have coming subject as physics, chemistry, math, and biology, and let's say another subject computer science. So if you ask one person to learn all the subjects, okay, there is a person P1, let's say, learn all the subjects and give this quiz. What will happen is that uh, it might be the case that it will not perform well. But in the case that uh, you give, let's say, P1 person, P2 person, P3 person, and so on, different subjects. Let's say you give person P1 math subject, you give person P2 biology, third person you give chemistry, and so on. And if you not take the quiz, the score will obviously increase. It's highly likely the score will obviously increase. Okay, because you are dividing the work. We are dividing the work. There is one more key aspect to notice here. Let's say the person P1 is good at maths, and the person P2 is, let's say, good at chemistry. So we'll try to assign that person P1 gets maths to learn and person P2 gets chemistry to learn. So we know beforehand, okay, that if it is a binary classification, then probably logistic regression will work good rather than some other thing like linear regression, because obviously it's meant for regression and it's for classification. Also, let's say there are multiple features, multiple class outputs, let's say A, B, C, D. So you may tend to use naive Bayes, basically multinomial naive Bayes. So this whole thing is that the two things we have to keep in mind. First point is what? Division of work. And second thing, efficient distribution. I think these 2 points might have hit you properly. Like this is the main crux of ensemble learning. Right. In short, if someone asks you in nutshell in a naive language, what you can say, it is that teamwork of different models. Right. So since we have got the intuition of ensemble learning, now we can move to have a look upon different ensemble learning methods. So we have ensemble learning. It can be broadly classified into two classes. Number one is sequential ensemble method, and second is parallel ensemble method. Okay, so let's try and have a look on each of them. Firstly, we'll go with sequential ensemble method. The first point is that base learners are constituted. You give output, you give input, and you will be passing to simultaneous models, multiple models simultaneously, and getting the output. If we consider a real life example of it, let's say you have a chair to be made. So this is a chair, not a good looking chair. So let's say this is a chair. Okay, and this is a chair. So what you'll do, first person will go and cut the tree. Okay, second person will go and transport it. Third person will shape it. Fourth person will polish it, and fifth person will deliver it. You know how? These 5 persons are working in series to deliver the final product. So this is the best example of sequential ensemble method. We are using the qualities of each and every different model to achieve our final goal, that is the output. There is an example, you have a chair to be delivered. First, one person will go and cut the tree, second person will transport it, third person will shape it, next person will they'll polish it, and the final person may deliver it. There might be all multiple steps inside these steps also, but for the base case, you can consider this. Okay. So, what is the basic motivation behind sequential learning? That uh, overall performance can be boosted. How? Let's say these all 5 steps. These all 5 steps. 1, 2, 3, 4, 5. Was to be done by single person P1. What will happen? That the same person will go fetch that board, it will transport it, it will shape it, it will polish it, and so on, and that will reduce efficiency obviously, because it's so much work to be done by single person. So this doesn't makes it efficient. We are using dependence. Let's say the person 2 is dependent on person 1. That okay, if you don't cut the wood, I will not be able to transport. I will not be able to transport. So that's the thing that we are using dependence here. One model over another. Okay, and that will finally give us output. Okay, so this is the basic crux of sequential ensemble methods. Next, we have to look upon something called as parallel ensemble methods. Okay. This is the thing where we are trying to do something parallel. As the name says, we are trying to achieve something by performing parallel operations. Okay, and basic motivation is here, we are using independence base learners. What is, let me just give a light on dependence and independence of base learners. These are base learners, let's say. Base learners. There's two things, they can be dependent and they can be independent. What will happen? That if they are dependent, you cannot perform another step without the output of the previous step. So the actions happen in series. This 2 is dependent on 1. But in the independent case, what we have, if we have model 1 and model 2, process 1 and process 2, they can go on simultaneously. Live example of that, that dependent we have understood. Okay, if you don't cut the wood, what will happen? I can't transport it. But consider the example of independence. Let's say you have a mobile factory. There is a conveyor belt, okay, which performs various operations on and finally generates you and gives you mobile. Let's say you were to generate 10,000 models, basically mobiles per day. Now, if you were to increase the performance, what you will do? You will parallelly put another conveyor belt and generate another 10k mobiles. So now try to understand that working of this will not affect this. Even if you stop this, it will still work, and if you stop this, it will still work, and both can work simultaneously. So they are independent. These two things are independent. On the same hand, the process is going inside this conveyor belt, this processing belt are dependent. So this is the best example of dependence and independent operations in machine learning or any user process. So next we can see and have a look at how we can picturize ensemble learning models. So as I have already discussed, let's say we have model 1, model 2 and model 3. We combine it and there will be a final ensemble model. We'll be doing input to it, and finally there will be predictions that will be done. Basically there is a combination model. Combination. It can be in series, it can be in parallel. Right. Next, why it is important, how it is important, and why it is important. Okay. So there are two factors. The significance, basically, significance of ensemble. The first point is robustness. And accuracy. Robustness is that we are using multiple models, so it becomes robust. In case some model is not be able to extract some feature properly, the another model might extract that feature. Okay, and accuracy obviously increases because we use multiple models, and in each and every step of this ensemble process, the accuracy increases because we try to rectify the error caused by previous model or simultaneous process. Okay, so there are basically two ways of using ensemble method. First way is that you can combine what weak models. Okay, and they can be large in number. Okay. And second way is that you can carefully choose strong learner, and they might be less in number. So this is the way we can go and approach this kind of problem. Okay, so there are basically two ways. Now, to move next, we can see that how we can calculate the accuracy of a model. Okay. Next topic is accuracy. Let's say we have prediction. Basically, for calculating accuracy, firstly we have to decide whether there is a regression or classification. So, if it is a regression problem and there is some output P1, P2, P3 from different models, what we'll do for calculating accuracy, or basically the final output will go P1 plus P2 plus P3 divided by 3. Basically n. What is the number? For the classification, we'll be taking what? Mode. Means the maximum occurring frequency. Cool. And the same way we'll be calculating accuracy based on these outputs. So that's it for this time, and next time we'll tend to see something called as weighted averaging and all. So that's it for this. Thank you.